Researchers using the NASA ESA Hubble Space Telescope recently took advantage of a rare opportunity to record Saturn when its rings are edge-on, resulting in a unique movie featuring both of the giant planet's poles. Saturn is only in this position every 15 years or so, and this favourable orientation has allowed a sustained study of the two beautiful and dynamic aurorae, Saturn's own northern and southern lights.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope, travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Hello and welcome to the Hubblecast. It takes Saturn nearly 30 years to orbit our Sun, and so chances to view both of its poles simultaneously are few and far between. Now, Hubble's been snapping pictures of Saturn's aurora since 1990. But 2009 brought the rare opportunity for Hubble to image Saturn with its rings edge-on and with both of its poles visible. As Saturn was approaching its equinox, both poles were equally illuminated by the Sun, allowing for spectacular shots of Saturn's active aurora.
An enormous and grand-ringed planet, Saturn is certainly one of the most intriguing bodies orbiting the Sun. Hubble has now taken a fresh look at the fluttering aurorae that light up both of Saturn's poles. These recent observations go well beyond just a still image and have allowed researchers to monitor the behavior of both Saturn's poles in the same shot over a sustained period of time. The movie they created from the data collected over several days during January and March 2009 has aided astronomers studying both Saturn's northern and southern aurorae. Given the rarity of such an event, this new footage will likely be the last and best equinox movie that Hubble captures of our planetary neighbour.
Despite its remoteness, the Sun is still Saturn's parent star, and, as we all know, the parent's influence is far-reaching. The Sun constantly emits a stream of particles, called the solar wind, which reaches all of the planets in the solar system, including Saturn. Now, when this stream of electrically charged particles gets close to a planet with a magnetic field, like Saturn or the Earth, the field traps the particles and bounces them back and forth between the poles.
A natural consequence of the shape of the planet's magnetic field, a series of invisible traffic lanes exist between the two poles, along which the electrically charged particles are confined as they oscillate between the poles. The magnetic field is stronger at the poles, and the particles tend to concentrate there, where they interact with atoms in the upper layers of the atmosphere, creating aurorae, the familiar glow that the inhabitants of the Earth's polar regions know as the northern and southern lights.
At first glance, the light show of Saturn's aurora appears to be symmetric with respect to the two poles. However, analyzing the new data in greater detail, astronomers have discovered some subtle differences between the northern and southern aurorae, and this reveals important information about Saturn's magnetic field.
The northern auroral oval is slightly smaller and more intense than the southern one, implying that Saturn's magnetic field is not equally distributed across the planet. It is slightly uneven and stronger in the north than the south. As a result, the electrically charged particles in the north are accelerated to higher energies as they are fired towards the atmosphere than those in the south. This confirms a previous result obtained by the space probe Cassini in orbit around the ringed planet since 2004.
These dramatic light shows observed by Hubble on Saturn are not just a charming feature, but they actually teach us something about the conditions on one of our most magnificent planetary neighbours. This is Dr. J, signing off for the Hubblecast. Once again, nature surprised us beyond our wildest imagination.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The ESOcast highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.